Hi everyone, I am JUN XIAN. So now I will discuss with you about the assignment question number 3. Given the ZL equal to 75 minus J100, and then we have to measure a 50 ohm line at 2 gigahertz. So what we want to do is to design a single short circuit shunt stub to match the line and load impedance. So the first step, what we have to do is to find the normalized ZL and YL by the given ZL and Z0. So as you can see here, when we want to do the normalize, we just use the load impedance divided by the 50. It means that ZL divided by the Z0. Then we get 1.5 minus J2 ohm. And then for the YL, we just is 1 over the normalized ZL. Then we can get the 0.24 plus the J 0.32 ohm. This one is our YL. The second step, we have to find the capacitance value for the capacitor at the load. Given the frequency is 2 gigahertz, that's so that we can find using the formula. Then after a comparison, we can get C equal to 0.7958 picofarad. The next step, when we using the Smith chart, the first what we draw the circle is the YL circle. Okay, according to YL, 0.24 plus J 0.32 ohm in the Smith chart. Then we draw a circle over here. After that, we draw a 1 plus JB circle over here. Here are two intersection point occur, which is Y1 and Y2. So after we determine the value, the Y1 is 1.0 plus J1.7, whereas the Y2 is 1.0 minus J1.7. It means in the opposite way. Then we can find the value of lambda first. So using the formula C equal to F theta, F lambda, then the lambda what we found is 23.87 millimeter. Okay, so when we find Y1 and Y2, we just put a straight line over here to the end, and then we can find the lambda value 0.181 for Y1 and 0.319 for Y2. And then for the YL, we can find also 0.052 lambda. So after we find these three values, we can start our next step. As you can see, from YL to Y1, the distance is 0.181 minus 0.052 lambda. Then after we do the calculation and multiply with the lambda, we can get the distance is 3.80 mm. And then the same for YL to Y2 from here over here. Then we can find that 0.319 minus 0.052. Then same multiply with the lambda, then we can get 6.37 millimeter. And then for short circuit stub, the Y is equal to infinity. So when we want to find the distance for the length of the SC circuit stub, then we can use the formula 0.25 plus the 0.181. It means that from here, you can plus until here, go until infinity. Then for the Y2, we're using the 0.319 lambda minus 0.181. It means from here, we just minus the value for here. Then the distance between these two, from here to here, is 0.138 lambda. Then after we multiply with the lambda value, we can get 3.29 millimeter. These two, D3 and D4 found is to determine the length of the short circuit stub. So there are two possible solutions. As we can see, these two figures, the first figure and the second figure, both the capacitance value are the same. Okay, and then the D1, which represent the distance from the Z0 to the single stub, is 3.28, which is our D1. Whereas the second is a D2. And then for the length of the stub, D3 and D4. So there are two possible solutions for the short circuit single stub. That's all from me. Thank you.